All right, y'all. So 5.1, like I said, deals with rational expressions. And y'all just remember, rational, that means they are fractional. Okay. All righty. So they start out in 5.1. They want us to find all numbers for which the rational expression is not defined. So they're basically saying, hey, what makes it undefined? Okay. So for number one, they're giving us 6c squared minus 10 over 9c plus 25. So this is what we had to do when we were actually finding domains. Remember, when we found the domains, we had to kick out all numbers that made the fraction undefined. Boom. So in 5.1, they start out, they just want to know what the numbers are. They don't want me to find the domain. They just want me to find any numbers that'll make that not defined. But we're going to do it just like we did with the domain, right? We're going to set 9c plus 25 equal to 0. Because remember, the only thing we're concerned about is the bottom of the fraction cannot equal 0. So now by solving for c, we can find any values that would actually make it undefined, okay? Because we're setting that equal to the 0. So y'all, we're just going to start out by subtracting 25. So this 9c will come down. That cancels on the left side. And then 0, negative 25, give me negative 25. And y'all, that step, divide by 9 to make that a 1c. So the 9's cancel, making that 1c. And y'all, we cannot do nothing to that. So that'll stay a negative 25 over 9. So MATLAB, it'll have the answer blank. It'll say the rational expression is not defined for, and then you put in your negative 25 over 9, okay? So we're not finding the domain on the first two. We're just finding out how to find numbers that make it undefined, okay? Now the second one, I got a z squared minus z minus 5 over z squared minus 16z plus 63. So here's the difference from earlier when we did domains back in chapter 2. We didn't have quadratic stuff on the bottom. We had things that looked like this first fraction had. So since we got a z squared here, that means there's going to be two numbers that make that equal 0 under there. So we're going to have to find both of them, okay? So set the z squared minus 16z plus 63 equal to 0. Now in this section, to solve these, we're just going to factor them real quick. You could use quadratic formula if you want to, or factor these. Because the z squared means a z and a z in front of both of these. Now remember, I'm going to focus on that last sign. The last sign of this is positive, so that means both of these factors will have the same sign as the middle number. Because remember, to get a positive, you could do a negative times negative. That's how that sign's positive. But they're both negative, like the middle, okay? All right, y'all. So what we would need now are factors of 63 that'll add to equal 16. So you can break out your numbers over here. 1 and 63, 3 and 21. Oh, y'all, I got one more. What is it? 7 and 9. Well, y'all, 7 and 9 equals 16, so I'm going to put them in. 9 and 7. So the numbers add to get the middle number. They multiply to get the last number, okay? All right, now to finish this out, set both of those equal to 0 and solve for z. So y'all, the first one, I'll add 9. I get z equals 9. Second one, I'll add 7, and I'll get z equals 7. So the rational expression would not be defined for z equals 9 and z equals 7. Now, y'all, I'll show y'all another way on this one. If you're weak at factoring, remember, these are the solutions. Well, we know the solutions are equal to the x-intercepts of the graph. So if we graph this denominator, we could graph it and solve it for these two numbers. So I'm going to show you all that just to get you all a little more practice at that. So I'm going to share my calculator. I'm going to go to y equals. Now I got to use x's instead of z's, but I'm only worried about that denominator. So I'm going to do the x squared minus 16x plus 63. So you always got to use x's on the calculator because it uses x's and y's. So no matter what your variable is, a c, a b, a z, use x's on the calculator, okay? Now y'all watch this graph. Remember, I said this equals 7 and 9. Watch where the x-intercepts are. So it's a little hard to tell that it's coming under and over there. But y'all, if you go to second graph and go to that table, and you arrow down towards where that parabola was going under the line, you can see that you got a y value of 0 at the x value of 7. And then there's the x value 9. And it also has a y value of 0. So if you're weak at graphing, factoring, graph it and see where those zeros are, okay? Because those are your solutions. All right, so then in this section, they said, hey, find the domain. So now we're actually going to find the domain. Now they want this to be written, so they're saying write both set builder and interval notation. Okay, so write both in set builder and interval notation. So these will start around 3, 4, and 5. There's only like 5 altogether on here. Yeah, there's 6 altogether. So I'm going to do a few of these just to show you how to get into the groove of them. Now, y'all, so I'll do like number 3 here. They got a f of x equals 6x minus 7 over x plus 2. So I will say this. We've only got an x down here, 1x, So that means we're only going to have one number we got to exclude, okay? So what we want to do is set x plus 2 equal to 0. We're going to solve this by subtracting 2. And I get x is a -2. So for my set builder notation, we would have x such that x is a real number and x cannot equal a -2. All right, then you got interval notation. Now remember, when you're dealing with fractions, interval notation is going to start at -infinity and it's going to end at +infinity. And we use a union to kick out the numbers. So y'all, here we go. So we go from -infinity until we hit -2. We're going to kick out that -2 by doing a union around it. And then since -2 is the only number I'm kicking out, the rest of my domain heads off towards +infinity. Okay? All right, y'all. So like I said, this is a 5 over 2x minus x squared. Um, this is just really just more practice doing domains on fractions though overall. All right, so I got an x squared under here. So that means I'm probably looking for two numbers to kick out of this domain, okay? So what I'm going to do is take my 2x minus x squared, set that equal to 0. So now I would put this in order and try to solve it using quadratic stuff. But y'all, I want you to see this. This is an x squared term and an x term. We can solve this pretty quick if we factor out a greatest common factor. Because look, both of these got an x in them. So I'm going to factor out an x, and that'll leave a 2 minus x, all of this equal to 0. So whenever I got two terms and they got a greatest common factor, I factor that out so that I don't have to worry about trying to factor a big quadratic or doing the quadratic formula. So all I did there, I factored out the GCF. But now I got two factors equal to 0, so I can set both of these equal to 0 and solve them for the x's. Well, y'all, here's the single x. Every time we had a single x out here, it always equaled 0. And we did that the other day in, what was it, like 8-2, when we were playing with factoring, sort of. Now this one, I'm going to have to solve. And y'all, I'll tell you the quickest way to solve this one would be to add x to both sides. Because since your x is negative on this side, if we add an x, all we got over here is 2 now. And 0 plus x is x. So we get 0 and 2 as the two numbers we got to kick out. So for set builder notation, x such that x is a real number and x cannot equal 0 and x cannot equal 2. Now, we'll tell you this. These numbers got to be in this ascending order. The smallest number and then the largest number, okay? Same thing with your domain when you write it in interval notation. It's got to go from left to right as you would hit them numbers. So we would hit 0 first. So we're going to union around 0 to kick it out. From 0, we would cruise along until we hit 2. So we're going to union around 2 to kick it out. But then we've kicked out all the numbers we need. So we're headed off towards our positive infinity. Okay, so be careful that these are always in the right order. So y'all, I'll do one more in this section, and then we're going to get into the 8-5. And y'all, for the most part, I'm hoping this is definitely like a review for you, okay? All right, so this one has the x to the third minus x squared plus the x plus 4 all over x squared plus 11x plus 28. All right, so we know we got to set that bottom equal to 0. And we got 3 terms on this one, so you want to factor it or use the quadratic formula to solve this one. So I'm going to actually factor this one. So I get an x and an x. But y'all remember, the other way that you could find your 2 answers. Graph this bottom. Graph this in y equals, and look where this graph is going to cross over the x-axis, okay? All right, y'all, so if I'm factoring it, the last sign's positive, so both of these factors will have the same sign as the middle number, so they're both going to be positive. So if the last number is positive, you got to have like signs in these parentheses, okay? Either both positive or both negative. All right, y'all, factors of 28 that will add to equal 11. So let's see, 28 is 1 and 28, 2 and 14, and then what? 4 and 7. The pair I need are 4 and 7. All right, y'all, so we got it factored. Now let's find our zeros or our solutions, right? So both of these were positive. So all we're going to do now is what? Make them both negative by subtracting. Now, since these are both negative, MathLab made it a point that you better put these in ascending order. Okay? So set builder, X such that X is real and X cannot equal. Well, y'all with me see. Going left to right, which number comes first? Would you put the -4 first or the -7? All right, y'all, I'm about to look on my chat and see what y'all are saying here. So good job, Jackson. I would definitely put that -7. And then X cannot equal or -4. So good job. If y'all don't get them in the right order, MathLab is definitely going to mark that one wrong, okay? All righty, so here we go. So negative infinity to -7, union -7 to our -4, union around -4 to kick it out, and then we're off towards positive infinity. So every other number other than -7 and -4, I can put into that function and get a real number out of that, okay? All right, y'all. So that basically was the 5.1, okay? Mainly a repeat of what we were doing earlier in here. We just added the quadratics to it, okay? So now let's actually look at 8.5, and that deals with rational functions. Now, y'all listen. The first two problems in 9.5 are doing two domain problems. So I'm sort of going to skip over those because we just did a lot of domain problems for 5.1. So the first two in 8.5 are just like 5.1. So I want to get into the part of 8.5 where we deal with what we call asymptotes. Okay, so let me give us a few definitions here. So the first definition is what we call a vertical asymptote. All righty. Now these asymptotes are really what we would call imaginary lines, okay? So for the vertical asymptote, it's an imaginary vertical line that the graph cannot cross. Now, why can't a graph cross this imaginary vertical line? Y'all, that's because they occur where the function is undefined. Okay, so if you got an x value that makes your function undefined, then where that graph crosses over that x value on the graph, it can't cross over it because it's undefined. How can you put a point on that line if it's undefined? So they occur where your function is undefined. They come in the form of an equation. So they come in the form of x equals some number. So if my function was undefined at 5, then my vertical asymptote would be x equals 5. It would be a vertical line that occurs at the x value of 5, okay? So to find the vertical asymptote, we set the denominator equal to 0. So the same thing as the domain, right? We set the denominator equal to 0. And solve for the variable. So since the variable is x, once you solve it, you're going to have the answer we need. X equals 5, x equals 2, and so on, okay? So I'm going to sort of show you what an vertical asymptote looks like on a graph. So y'all let me go out maybe about 5 here. All right, so say I'm graphing something like my function is f of x equals 1 over x minus 2. Okay, so just say I'm going to graph this function 1 over x minus 2. So, y'all, let's set the bottom equal to 0 so we can find our vertical asymptote. And to do that, we would what? Solve it for x, and we get x equals 2. So that'd be my vertical asymptote. So that means over here at the x value of 2 right here, I got a imaginary vertical line that my graph cannot cross over. So if you were to find you a lot of x values to put in for this function, you would find that it sort of comes down, crosses over, and then shoots downward. Now the other side would come down and it sort of crosses on top of this x-axis. But y'all, this side here, it's going to keep going down, down, down towards negative infinity, but it will never cross over that line. Same thing for this part. It's coming in from up here at positive infinity, but it never crosses over this imaginary vertical line because every point on this vertical line has an x value of 2. In our graph, cannot cross over that because it made it undefined. Okay. So that basically is our horizontal asymptotes. They're just little imaginary lines that happen where my denominator is undefined. So we got another one. It's a horizontal asymptote. Now I can actually show you what it is on my graph. You see, as this graph goes out towards infinity, this top part of this graph is coming down, down, down. It's trying to get close to the x-axis, but as it goes out towards infinity, it gets closer and closer to the x-axis, but it never touches it. So this means a horizontal asymptote is an imaginary horizontal line that the graph tries to approach. In either direction. Okay, out here at this negative infinity side, it starts out here close to that x-axis, but it never gets close to it. And it comes down, and then this right side slings in, and it tries to get close to that x-axis, but it never gets there. Now, these will come into form. Well, y'all think about this. If the vertical asymptotes were x equals a number, these are horizontal lines, so these will be y equals some number, okay? Now, I'll tell you how we find a horizontal asymptote. We got three cases of horizontal asymptotes, okay? Now, to figure out what the horizontal asymptote is, we compare the degree of the top to the degree of the bottom. The degrees are the highest exponents, okay? So we're looking at the highest exponent on top and the highest exponent on bottom. If the degree of the top is greater than the degree of the bottom, so if the top has bigger exponents than the bottom, then it will not have an asymptote because those values are going to head off towards infinity. So if the degree of top is bigger than the bottom, there is no horizontal asymptote. Second case, if the degree of the bottom is greater than the degree of the top, well, y'all, I had one here. I had a degree one on the bottom. There's no variable on top, so it was the degree 0. So my bottom degree was greater than my top degree on this problem. Well, what are these graphs trying to approach as they head out towards infinity? What is the y value for the x-axis here? Because that's where these lines are trying to get to. So y'all, if your lines are trying to get to the x-axis, what's that y value on anywhere on this x-axis? Oh, y'all look here. Y value 1, 2, 3. Y value -1, -2, -3. What's that y value right here on that x-axis? Well, that is 0. So if the degree of the bottom is greater than the degree of the top, then it'll be y equals 0. All right, so I had a case if the top was greater, no asymptote. If the bottom was greater, it went to 0. Well, the other choice would be if the top and the bottom were equal to each other. So if the degree of top equals the degree of the bottom, then your asymptote will be y equals a over b, where a and b are the lead coefficients. So y'all, what that means is I'm just going to sort of show you an example. Say I had something like 3x to the fourth on top, and on bottom I had like a 5x to the fourth, and then blah, 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 blah. Well, these degrees would be equal. So A over B for this one would be the 3 over 5. Those are my lead coefficients, okay? So for this problem, I would get y equals 3/5, okay? So that's what we're talking about, lead coefficients. And then my degrees were equal on that, okay? All right, so that's just an example, not in the actual definition. So you got the three cases for that, okay? All righty, y'all. So let's play with an example. And y'all let me see. These start at about number 3 for this one. Remember, 1 and 2, we're just doing the domain stuff. So for this example number 3, list all the asymptotes then graph. Now, you're not actually going to have to graph them by hand. They're going to have 4 pictures, and you're just going to pick the picture that looks like what you need, okay? So y'all, let's look at this. I got R of X equals 3 over X squared minus 100. So now, in here, when they say oblique asymptote, we just put none on this, okay? Because we don't do problems in here that's got oblique asymptotes. So anytime you say that, see this as a question, oblique, you're going to put none on that, okay? So all we're dealing with are vertical and horizontal. So let's find our vertical asymptote. Well, to find the vertical asymptote, I set the bottom equal to 0 and solve. So y'all, an easy way to do this one, you could factor this, but since it's just an x squared term and a number, remember, I can get the 2 answers by square root stuff. So I'm just going to add 100 and do my square root. All right, y'all, square root of x squared equals a square root of 100. So we know that that is now what a x equals a plus or minus 10. Um, so in MATLAB, it'll ask you vertical asymptotes are. In MATLAB, you would put x equals 10, comma, x equals negative 10. Vertical asymptotes got to be in the form of an equation if they don't give you the x equals part, okay? All right, y'all, horizontal asymptote. So y'all, here's my function. Is the degree greater on the top? Is the degree greater on the bottom? Or are the degrees equal on this one? What y'all putting? So where is my degree greater? So greater at the bottom. Good job. Y'all, we don't even have a variable on top. So the degree of the top is 0. It don't even have a variable. The degree of the bottom is 2. Okay? So the bottom is greater. So since the bottom is a greater degree than the top, our asymptote is y equals 0. So automatically, if the bottom is a higher degree, you put y equals 0. Okay, so that's my horizontal. Now, to pick out my graph, I do know one thing, don't I? One thing I know about this graph, over here at negative 10, over here at positive 10, my graph cannot cross them 2 vertical lines. See, on this one, since I had x squared down here, that gave me 2 vertical lines, okay? So what I usually do, I'll show you. There's 2 of them that they got that done. They got the B and the D. Well, what I got to know is my graph like an upside down U here, Or is it like a right side up U on this one? So y'all, how do we find that? We're going to go graph it, okay? So you got to be careful when you graph these, because if you mess up the fractions and stuff, it messes up your what your graph will look like. So I'll make these look like fractions by hitting alpha, y equals, and enter. On the top, I had a 3. If I arrow down, I put in my x squared minus my 100. Okay? Y'all, that is one way to do this. The other way, if you don't have the y equals, alpha y equals, that gives you the fraction notation, you got to do it like this. 3 divided by parentheses x squared minus 100. If you use parentheses around the bottom, it will give you the right fraction, and it will treat this as 3 divided by the x squared minus 100, okay? So either way you can do it, but you better put parentheses around numerators or denominators that have more than one part. All right, y'all, so let's see if that U was upside down or, all right, what happened here? So, oh, y'all, I bet I know what's happening. Let's see. Let me zoom that out a second because all right, y'all, let me do one thing real quick. Let me switch my calculator because this one I don't like it. So I'm gonna go back to my CE. All right, here we go. So I did alpha y equals enter. I had what, a 3 on top, and then the bottom was x squared minus 100. We might not be seeing this one because the numbers are so large. So let's try this one and see. Oh, I can at least tell how the graph is going. It is on the bottom making a U. So if I wanted to see more values, I could go to my window, and instead of them x's going to negative 10 and 10, I could do like negative 20 to 20. Because, and I'm not worried about the y values. Now when I hit graph, oh, it's still jacked up looking. Because they're not making those asymptotes all the way down, y'all. So watch this. So my numbers were pretty big with that 100 here. Let me see. Some of y'all are going to get easier numbers. So I'm going to do easier number real quick and see what happens. So instead of that, I'm going to say 49 on the bottom. That's a perfect square, just to see if y'all be able to see y'all's graphs. Yeah, so you can see them. It's just because my numbers were so big, it was making my graph a little bit wacky looking, you know. But the long run, I did see that that bottom part went down like this. So this part was like that, and then this part like that. So play with them windows if you got to make them graphs sort of look what you need, okay? Because all I was worried about, what was this part doing? Was it upside down or was it like a U, okay? Y'all, that's why they don't make y'all graph these things. Whoo, you would need a lot of points to graph these. All righty, so the next one, two, three, the next 4 problems, we're going to find the vertical asymptotes. No graphing. So that number 3 that I just did, that's the only one you really got to graph. So find your vertical, your horizontal, and then pick the graph, okay? So these ones starting at 4 want us to find vertical asymptotes. So y'all, here we go. F of x equals x minus 8 over x squared plus 5x. So we're basically doing the same thing we did with the domain. X squared plus 5x is going to be set to 0. We're going to solve it now for x. But y'all look here. You got an x squared term and an x term. They both have a GCF. So the easiest way to factor this would be to factor out a GCF of an x. Okay, anytime you got an x in every term, your first move is to factor that out, okay? So that leaves me an x plus my 5 in parentheses. Well, we know what the single variable equals. The single variable always equals 0. And then we said x plus 5 equal to 0. And we would solve that by what? Subtracting 5. And we get x is -5. So they'll have an answer where they got both of these listed. Choose that one, and we move on. So y'all, I'm gonna let y'all let me see what I got. X minus 6 over 3 minus x. How about y'all give me the vertical asymptote for this problem, and then we'll do a break. So I need one of y'all to tell me what is the vertical asymptote for number 5. Oh, y'all, let me pull my chat up so I can see when y'all answer. Well, I will say Chase and Macy are pretty close, but oh, Nat saved y'all. Remember, Chase, you and Macy, remember, if it's a vertical asymptote, you got to have that equation form. Okay? So let's see. Eve, I think what happened on yours to get that, you must have pulled the 3 over, but you would have had a negative x still. So on that one, the quickest way to be add an x to both sides and you get x equals 3. But let me show you what happens if you move the 3. You still have a negative x equal to -3, okay? So you still got to make the x positive by dividing by the -1. So that you get x is a +3. All right, y'all. So remember, in MATLAB, make it look like an equation. All righty, y'all. So 10:50, I will see y'all at 11, and we will finish out our 8.5, okay? All right, y'all. So take a break, and I'll see y'all in 10. All right, y'all, showing 11 o'clock. So let's finish out our 8.5. All right, y'all, so number 6 here. Same thing, finding our vertical asymptotes. That equals -3 over x plus 2, x minus 4. All right, so we're sort of happy on this one because they've already got it factored on the bottom. All we got to do is take the bottom and set that whole thing equal to 0. And then solve each of our factors. All right, y'all. So once again, the zeros are going to be opposite signs than our factors. So we'll make the 2 negative by subtracting. And then the 4 is going to become positive by adding. So y'all, once again, put them in MATLAB as an equation, okay? All right, then the last one here, until we get to the horizontal, x squared plus 2x minus 8 over x squared minus 3x minus 10. So y'all, listen here. I'm going to give y'all a few minutes and see if y'all can find me the 2 vertical asymptotes for number 7, okay? So this will be on y'all. So x squared, so y'all got to give me 2 asymptotes, okay? I just want to see how y'all's factoring is. So what I'm getting, -5 and 2. So you got that factored. Good job. So let me catch up with you. So x minus 5, x plus 2 equals 0. Because y'all, that 10 was negative this time, so you had unlike factors. And then they had to subtract and equal 3. So 5 and 2 subtract to get 3. The larger number has to be the same sign as the middle. All right, so let's see. You got me factored, so let's knock it out to get those 2 asymptotes. All right, so it looks like we're going to get, what, a +5 here? And then a -2 on this one. Well, y'all, there we go. X equals 5, comma, x equals -2. So, y'all, that's your verticals. But like I said, it's nothing new. It's the same thing as the domain stuff, okay? So the one that's going to be different will be our horizontal asymptotes. So these next 3 examples, they want us to determine the horizontal asymptote of the function. I remember I gave you I gave you 3 cases. The top degree higher than the bottom degree, no asymptote. Bottom degree greater than the top degree, the asymptote was y equals 0. If they're equal on top and bottom in the degree, then we went with y equaled a over b, where those were my lead coefficients, okay? So those are the 3 cases. So let's see which one we have with number 8. I got a 2x to the 4th plus 5 over 5x to the fourth minus 3. So, y'all, this is on you. What is my horizontal asymptote? If I got one. If not, put none. So what I need to know is, what is my horizontal asymptote? Okay, so they are equal degrees. You got a degree 4 on top and a degree 4 on bottom. So now, if they're equal, what does y equal? What will y equal as my horizontal asymptote? Oh, not 0. Remember, 0 was if the bottom was bigger. Remember, if they're equal, what we're looking at are these numbers in the front. Remember, this is your A over B is your lead coefficients. So it'd be A over B, which will be what? 2 over 5. All right, so Macy, replace the A and B with your 2/5 and be good with it, okay? All right, so equal, y'all. Look at the numbers. So let's see what number 9 did here. Okay, for 9, they got f of x equals x squared minus 4 over 5x to the fourth plus 7. So, first of all, is the degree greater on top? Is the degree greater on bottom? Or are these degrees equal? So the bottom is greater. Bottom is greater. Okay, Macy and Eva, y equals 0. Perfect. Y'all, 4 is greater than 2. So since the bottom's greater, it automatically became y equals 0. Good job. All right, y'all, 10 has f of x equals, ooh, this one's a long one. X to the third minus 3x squared plus x minus 4. All of that's over x squared minus 18. So where is this one greater at? Or are they equal? And what would y'all put as the horizontal asymptote or no horizontal asymptote? All right, good job, y'all. 3 is greater on top. So that means the top is greater. So no horizontal asymptote. All right, so it had to end with a graphing one. So the last question was a graph, sort of putting it all together. So check this one out. They want to list the domain. So the domain, they want it in interval notation, okay? Then they want the x and y intercepts. So I'm going to show you how to find the x and y intercepts. Um, and let's see, then they want the vertical asymptote, horizontal asymptote, and graph it. Now, once again, when it asks for an oblique asymptote, you put none because we don't do those in here, okay? All right, y'all, let's see my function. F of x equals x plus 6 over x squared minus 36. Now, y'all, what's nice is they want me to start out with the domain. Well, I know that the domain is found by setting the bottom equal to 0. So if I find the numbers I kick out of my domain, I'm also finding the vertical asymptotes, because the vertical asymptotes occur where it's undefined, okay? And undefined are the only numbers we kick out of our domain. So to get that domain, I'm going to set x squared minus 36 equal to 0. Now, x squared and a number, I'm going to solve this one by square roots. So I'm going to add 36. I get x squared is 36, y'all, and then we're going to square root both sides so that x comes out. I get a plus or minus. You always got to use plus or minuses now when you do square roots. And that'll be what, a plus or minus 6. So the domain will start at negative infinity. We hit -6 first, so we're going to union around that -6 until we hit the +6. Then we're going to union around +6 until we get to positive infinity. This is our domain. Okay. But I've also solved it already for the vertical asymptotes. They'll be x equals 6, x equals -6 when they ask me that question, okay? So the first thing they wanted was my domain, then the x and y intercepts. So y'all, to find the x-intercept, you find f of 0. Whoops, my bad, my bad. I'm doing the y-intercept first. So y'all, find the y-intercept by finding f of 0, okay? I'm trying to find what order they're doing these. Oh, they just do them both, and then the questions are based on what you find here, okay? So to find the y-intercept, you're finding f of 0, which means you're putting zeros in for the x's. So you got 0 plus 6 over 0 squared minus 36. All right, so 0 plus 6 gives me a 6 on top. 0 squared is 0 minus 36, gives me a -36 on bottom. And y'all, that will reduce to a negative, well, 6 and 36 are both divided by 6, making that a -1 over 6. So this is the y-intercept, and it actually equals 0 for the x and -1/6 for the y value. Okay. Now, to find the x-intercept, you set the numerator equal to 0. So you're going to set the top equal to 0. So y'all, that would be x plus 6 equals 0. So what do we do? We're just going to subtract 6 from both sides to solve that. And I get x equals -6. But y'all, here's the question of the day. Can I have a x-intercept at this value when x is -6? Because look over here what's happening. We said there's a vertical asymptote at -6. Down here in the domain, we said -6 could not be a value that you put into this function. So since this x equals -6, we got to throw that answer out, okay? Because the function is undefined at this value. So when you look at an x-intercept, you better make sure its number is not thrown out of this domain. Since this number was thrown out of the domain, that means that there is no x-intercept. You can't have an x-intercept if the function is defined at that value, okay? All righty, let's see what was next. Well, the vertical asymptotes. We've already solved it for when this thing was in the denominator, right? So the vertical asymptote's automatically going to be x equals 6, comma, x equals -6. Okay? Because we solved it right there. So that answer has two places we're using it, okay? Horizontal asymptote. Well, here's your function. So your degree on top, since there's no exponent, is a 1. Your degree on bottom is a 2. So y'all, what is my horizontal asymptote? Since that bottom has a higher degree than the top. All right, Eva, what y'all got? Okay, y equals 0. Good job. Okay, y'all, so now let's see what we look at when we graph this. Well, we know we got two vertical asymptotes. We got one at 6 and one at -6, we said. So over here at -6, and over here is a +6. We got vertical asymptotes. Our y-intercept up here is 0, -1, 6. Well, y'all, that's really close. But 0 and down -1, 6. We're going to say that's about right there at -1, 6, okay? Barely below that line. The horizontal asymptotes were y equals 0. So as this graph goes towards -infinity and infinity, it's going to try to get to these lines, okay? Now, we said there was no x-intercepts. So our graph does not cross over the x-axis. So y'all, I know what's going to happen here then. Because if this cannot cross over the x-axis, both sides of this have no choice but to go down, right? They both got to go down. They can't go up because there's no x-axis. There's no x-intercept. We said there was none. So that means it's not crossing the x-axis. So y'all, if both of these are going down, these two sides are going to come in and go up. And as it goes out, these lines are trying to get to that 0, but they never get there, okay? So once again, they'll have one where the parabola is sort of upside down like that, and one where they're opening upward, okay? So y'all, that's the trick in 8.5 and 5.1 is mainly dealing with these fractions and dealing with setting the bottom equal to 0, okay? Now, what I'm going to work on a little bit is the 5.1 support and the 8.5 support. I won't do them all, but I just want y'all to see some of the problems that are happening in them, okay? So let me start with a few in the 5.1 support. And these were just to get you ready for factoring because we had to do some factoring today. So y'all, number one, 10 x squared plus 5x. Now, they don't want me to solve this. They just want me to factor it. Well, y'all, what did I do every time I had x's in both of these? If I got an x in both of these, I'm going to factor that x out because it makes it a little bit nicer. But what else do they got in common? Well, 10 and 5, they both have a 5 in them. So my greatest common factor will be a 5 and an x. All right, so 10 divided by 5 is 2. X squared divided by x is an x. And then it's plus 5x divided by 5x is 1. So now if I had to solve this, I would set 5x equal to 0, 2x plus 1 equal to 0, and get my solutions, okay? But y'all, all they wanted me to do is factor in this class, okay? Look at number 2. R to the 5th plus 10r to the 4th. Well, let's see. Both of these have at least 4 r's in them. This is 5 r's and this one has 4 r's. So the GCF of this one would be R4. You notice I'm picking the smallest exponent each time. X to the first, GCF. R4 was the smallest exponent, GCF. All right, let's see what we get. R5 divided by R4 leaves you a R plus 10R4 divided by R4. The R4s cancel, leaving me my 10. Okay, so they're going to do a few working with the GCF. Then they get into the trinomials. T squared plus 14t plus 48. So we know that's going to factor into 2 parentheses. Okay, also, here's what you got to factor. What does this actually factor into? What would you put into my 2 parentheses? Oh, you know, Jackson, I think that's 7. I think that's a 48, not a 49 at the end. There you go. What are y'all putting now? 8 and 6? Good job. So y'all get a T plus 8 and a T plus 6. So they're both positive because the last one's positive. Both of these factors are positive like the middle. And then factors of 48 that had to get 14 were 8 and 6. All right, y'all, V squared minus 5V plus 6. So what are y'all putting in these parentheses? Oh, well, hell, I'll put the V down at least on the front. How about that? On that, you're on the right track, but -6 times 1 is going to give you a -6 at the end and not a +6. So y'all watch this. That last one's positive, so both factors are going to be negative like the 5. So remember, the only time you're going to have unlike signs is if the last one's negative. So the last one's positive, you got to have like signs. And then remember, I want factors of 6 that add to get 5. So that'll be 3 and 2. Okay. So if you foil this back, you get -3v, -2v, that gives you -5. And then -3 times -2, give me +6. All right, y'all, r squared minus 28 minus 3r. So tell me the first thing y'all would do to that one. So the first thing I would do to this problem, I'm probably even going to do this before I put my parentheses down, okay? All right, good job. You do want to arrange this, y'all. So do the r squared minus 3r minus 28. All right, now we'll factor this. So I know I got an r and an r. So y'all, what's going into parentheses? Okay, 7 and 4, good job. So here's the thing on this one, y'all. The last one is negative. So you automatically got unlike signs no matter what. All right, all right. Oh, and y'all even got my signs now. So I need a -7, good job, and a +4. So just remember, unlike signs, larger number, same sign as the middle. All right, 4y squared minus 16y plus 16. All right, y'all, there's one thing I'm going to do before I try to factor this one. Look at all three of these numbers, a 4, 16, 16. When you got all three numbers that'll divide by one of those numbers, I pull that number out like a GCS. So these three numbers will all divide by 4. So what we're going to do, we're going to factor the GCF out like we was doing up here to start it. So I'm going to divide everybody by 4. 4 divided by 4 gives me a y squared minus 16y divided by 4 makes that a 4y plus 16 divided by 4 makes that a 4. So this one, we factored out the 4. Now we got to factor this part. So bring the 4 down. So this one's almost a two-step factoring, okay? Factor out the GCF, then factor this. So y'all, that's the first step I did, factor out the GCF of 4. All right, y'all, what's going into parentheses? We know we got a Y and a Y. So what would y'all put in here? What y'all got, Nat? -2, -2. Good job, y'all. Last one's positive. Both of these are negative like the middle. And then factors of 4 that had to get 4 were 2 and 2. So y'all, that's 5-1 support. Let me find something. I thought I had 8-5 here too. So okay, I got 8-5 right here. So let's look a little bit at the 8-5 support. Now 8-5 support just had 3 problems. But 8.5 support was more factoring. All right, y'all, hang on 1 second. I gotta find something. I'm gonna zip into MATLAB real quick. I gotta look at how to put that up in there. So I'm zipping through the portal now. So let me get signed in. I tell you, our portal's been a little slow at times. We just got about 20 links to get through, though, to get there. So I'm almost to math lab. So I can't leave it up to whole class because math lab times out on here. All right, so I'm looking at 8.5 support and preview. Okay, so I was just making sure I had the right problems. All righty, so 8.5 support, y'all. These will say simplify by removing factors of 1. So what they mean by this, say I got 5y minus 30 over 5y plus 30. The first thing we want to do to these is some type of factoring. So notice on top, you got two terms. What do the top two have in common? They both have a 5. So it's like doing the 5-1 support, but here you're factoring top and bottom, okay? So on top, I'm going to factor out a 5. So I'm going to factor out GCF of a 5 on top. Well, 5y divided by 5 leaves you a y minus 30 divided by 5 is 6. Look at the bottom. No, the bottom has a 5y and a 30. So on bottom, I'm going to factor out a GCF of 5. So I'll factor out a 5. 5y divided by 5 leaves you a y plus 30 divided by 5 is a 6. So you got to factor it, and then this makes sense. It says simplify by removing factors of 1. Well, y'all, over here, if stuff matches up perfectly, you got a 5 divided by 5. Well, 5 divided by 5 equals 1. So that's what they mean, okay? Now, the y minus 6 does not look like the y plus 6. So this part cannot simplify. When you got factors like this y minus 6, you can't come in and cancel out the y. That's not what happens. You got to cancel out a whole factor when you factor and cancel by factors, okay? Single factors you can cancel, but binomial factors like this only cancel when they look as exactly the same. So this final answer would be y minus 6 over y plus 6, okay? We don't cancel single terms, we cancel factors. And y'all, you're going to see somewhere I can cancel the factors like this, okay? All right, p squared minus 25 over p squared minus 10p plus 25. All right, so the top, you got a p squared in a number. Now, if I was solving this, I would do the square root stuff, but y'all, they want me to factor this. So p squared minus 25 factors into conjugate pairs. You got a p and a p. the last number's negative, so one's plus and one's minus. Now, y'all, here's a trick on this one. Since there's not a p in the middle, we treat the middle number like a zero. So what factors of 25 will give me a zero? And that, what you got? 5 and 5. So check this out. When you got perfect squares, the square root of p squared is p and p. The square root of 25 is plus 5 and negative 5. Okay, so remember, this is perfect squares, and they always factor into conjugate pairs. All right, what's happening on the bottom? I got a p squared, that's a p and a p. All righty. What are y'all putting on bottom of this? You got a positive 25 and a negative 10p. What's that going to factor into? All right, good job. Minus and minus, remember, because they're both the last one's positive. Both factors are negative like the middle. And the factors of 25 that equal 10 are 5 and 5. So y'all, look what we got now. This p minus 5 can cancel with this p minus 5. But it can't cancel both of them. That factor is gone now. So what's left is a p plus 5 over p minus 5. Since they don't match up, p plus 5 over p minus 5 is our final answer. So y'all, there was one more. Z squared minus 9z plus 18 over z squared plus 4z minus 21. So it looks like we got to factor both of these. So I need someone to factor my top. And then we'll need someone to factor the bottom. So what am I getting on top? Z minus 6 and z minus 3. Good job. The last sign's positive. Both of our factors will be negative like the middle. And then factors of 18 that added to get 9 are 6 and 3. All right, y'all, how about my bottom? So what am I getting? A z plus 7, z minus 3. All right, so the bottom had a negative at the end, so unlike signs, and then we wanted factors of 21 that subtracted to get 4, 7, and 3, and that, the larger one, was positive like the middle number. All right, y'all, so now y'all see the magic, right? You got to get one of them to at least match up, okay? So the z minus 3's will cancel, leaving us a z minus 6 over a z plus 7. Final answer. So y'all, that's what's happening in the 8-5 support. And then the 5-1 support was a little bit of factoring also. So if you notice, all of the support today was aimed at getting y'all a little better at factoring, okay? Because sometimes factoring is a lot nicer than having to do that quadratic formula to everything, okay? All right, y'all, I'm just looking through. Okay, so looks like Monday will be pretty mellow because all we got is one more section left. And I don't like to review on the same day that I do a review. So, yeah, 9's not too bad, that stuff. So, um, we'll do 8.6 Monday. And I'll probably do a little review Monday. But I'll come back Tuesday and we'll do a real review before we start on any new material, okay? So let me stop our record.